Oh, we're live. Okay. I need to grab water real quick, but okay. We'll just do the intro while I'm off screen. Hello world. This is day 219. Is that the number? 219. I was studying compilers every day until I land a compiler role. Um, yeah. Last time we started doing more GVN reading, and we were gonna implement it, and then we got tired, so I decided against it. What's up, Panda? Good to see you. This time I was gonna continue doing like GVN, but I think we're just gonna take a quick break from it, and we're gonna do a little bit more cleanup work. Specifically, there's some like middle end stuff that doesn't really it doesn't quite map very well. I want the like literal map thing to, I guess, be a singleton instead of being stored like per program, which is like kind of awkward. So yeah, we should do that somehow. I think that's gonna be the big thing I want to do today, and then that lets us like split up inst combine a little bit more, and it's gonna hopefully be much better. What's up, Izrith and Joe? Good to see you all. Stay hydrated. We love water. Okay. All right. So if we go back to our code base, what did we change? Did I forget to commit things? Oh, yeah, I did forget to do that. Okay, let's do that real quick. Let's just add GVN. Scaffold out GVN more. Oh, we need to format? Okay, sure, fair enough. Let's do that. Here we mess with some imports, or remove duplicative imports, or extraneous duplicate imports. Okay. How many lines currently? Let's see. That many. Yeah, that many lines. So that many lines of C++, that many lines of header, that many lines total. Which is crazy, actually. Holy hell. I think the number was higher at one point, but it turns out deleting MIR helps. Or deleting HIR helps a lot with that. Following with audio only is very strange. Yeah, I feel ya. Hopefully some of this narration helps, but yeah, we'll see how that all ends up going. Okay. So instead of working on GVN this time, we're just gonna go back to refactor hell for a little bit longer. Yeah. So in Valley we have this literal thing. I want to make a singleton for the literal map thing. I think that lives in MIR? Yeah, we have that there. Is there a thing that uses this, or surely there's a, oh yeah, it lives in program, I see. So we should move this out somewhere. Yeah, so let's figure out, let's take a second to figure out how singletons work again. C++. So if you're not familiar with the singleton, the idea is, so a singleton is a concept in object-oriented design patterns, which is secretly code for we're programming against the language and the language features. Yeah, a singleton is one of those design patterns, and the idea is you basically make when it's not quite a global, but it's the object that is a singleton has only one instance at a time, pretty much. And that'll be useful for this. It's I'm actually not sure how to distinguish it from a global, but I guess it's in terms of how you want to use it, at least. Why you switch to Windows? I've been on Windows for pretty much most of this, actually. My laptop is running Arch, but I don't want to stream on my laptop anymore. And I'm on Windows here because Valorant, as Panda said. Okay. What is wrong here? Okay. So we don't want to do that. Synchronize? What? Yeah, anti-pattern. Is there an alternative? Let's see. Dependency injection. Okay, well, so that's like what we do, but it's like low-key annoying. Join Gen 2? Hell no. That's terrifying. Service locator. What the hell? Monostate. Oh, actually that makes a lot of sense. That's pretty cool. I didn't think about that. That's something we can do. I guess we could just like make it a global and call it a day. Do you avoid using any AI? I try to use it as little as possible, but yeah. I think I've been using it in some. I've been using it more and more over time, to be honest. Much to y'all's dismay. I think it's like very good at some tasks. I think it's very bad at other tasks. I think figuring things out is one of the tasks that, at least like when I know how to look up stuff, I think it's not really helpful for. Let's see. Yeah, like this is just really annoying, at least. I don't want to do it that way. For exploration? Yeah, exactly. I think like I don't know. The thing is like as long as you're not like turning your brain off, I think it's fine. It's very easy to just slap it out, but I think as long as you're like even like remotely just like thinking about what code is being generated, even if you use it to generate code, I think it's fine. Okay. This is annoying. Okay. Parameterize from above. Oh, that's bright. Okay. Well, it seems like I'm kind of doing it almost correctly. I think I shouldn't do it like this, though. I feel like I should pass it downwards. Yeah. Yeah, maybe if we, like, pull this out, I think that might be helpful, but let's see. Maybe we could maybe we could turn it into an object. I think that's, like, the least awful way to do it. Take care, Panda. Thanks for stopping by. Yeah, okay. Well, I'm not really sure what the best way to do this is, so. Yeah, maybe I should just like. I also don't like this like double like unordered map thing. This is a little bit ugly. But I guess it's like not the end of the world. I don't know. Let's see if there's like a better way to do things. Okay. I think we should just like do monostate. I like the idea of monostate at least a little bit more. Borgidium? That's pretty funny. Monostate pattern, C++. Yeah, okay. Stood monostate. Oh, that's different. Okay. Wow. Yeah, this is interesting actually. I haven't thought about this a lot. Okay. Well, let's give like a monostate pattern a try. I think that might be interesting. Yeah, and then we can kind of just like keep that around at least. That also means we don't really need to like keep this, I think. Let's look this up. More natural access syntax, that makes sense. That makes sense, that makes sense. No worse, yeah. Oh, okay. Well, surely Uncle Bob has a good take on this, right? Let's see what he says in the conclusion. Existing class. Da-da-da. Yeah, sure. What even is monostate? I guess it's a class where all the members like share state. So like, if all of its private fields are like static variables, for instance, then they will all share that. So like, I think there was an example here. Yeah, I guess like here's like a reasonable example. Let's turn dark mode, so your retinas don't burn. The idea is that its only fields are like static, so that they are necessarily shared by all objects of that class. Yeah, so like this is like pretty much exactly what I want, actually. We just avoid like singleton hell. Let's see what Uncle Bob wrote about this. Singleton exists. This makes sense. It's very ugly though. Destruction is undefined, sure. Okay, monostate. Let's see. Yeah, it's a little bit ugly. And then like this is all like Java, cuz like this is like the land of object-oriented design. So I mean, yeah. Yeah, we just make all of them static variables, pretty much. Like that. A delightfully twisted pattern. That's really funny. So the difference is behavior versus structure. So singleton enforces the structure, whereas monostate enforces the behavior. That's actually a pretty cool way to think about it. Oh my god, I just found a... Okay, I just saw a deranged message. We will leave that for future me to watch. Okay, anyways. Benefits, all that. Costs, so no conversion I don't think we really care about for now. If we need to rewrite it, we need to rewrite it. I guess that goes for singleton as well. Efficiency like scares me a little bit. Presence, that we don't care about, and platform local is unfortunate. I think it's like cleaner, but like singleton is like faster, or I guess like more efficient. This is like interesting. I don't really like the overhead of monostate, but I mean, I'm using like dynamic cast everywhere. I don't think making a monostate is like gonna be really the bottleneck. Yeah, I kind of like this monostate thing, to be honest. The more I think about it, it makes sense. I wonder if LLVM has any singletons in it. Managed static. Okay. Okay, so I guess like... Okay, let's look up monostate instead. Yeah, I mean... What is that? Okay, that's not what I care about. Maybe I should just like singleton it and call it a day. I don't know. I think we'll give monostate a try because I haven't played around with it before, so I think that might be interesting at least to think about. So we're gonna do that. Let's move literal map out of here. But we'll do that as we go. So we're in value. We have all of this stuff. Instruction should yoink value, so this is probably sufficient to import. Let's see, let's go down here. Class. We'll do literal map. And then, let's see. How would we make it a singleton, actually? I guess... what course do you take or major in? If you're asking, like, what my major is or, like, my area of study, I guess I'm majoring in computer science. Both my undergrad degree and my master's degree are in computer science. Yeah, I'm gonna assume that's what you're asking. I cannot completely tell. I can't completely understand. That's scary. Okay, perfect. Yeah, this is... I guess it's gonna be, like, gross anyways, so we're just gonna do it like this and call it a day. What's a minor? It's, like... It's kind of just, like, a secondary area of study. Usually, like, the requirements are a little bit more lax, but you don't get, like, the full, I guess, credential of a major. So, like, if someone were to, like, major in computer science, you would expect them to, like, have dedicated most of their time towards computer science. Whereas if someone were to, like, minor in computer science, you'd expect them to have, like, dedicated most of their time to a completely different field. But, like, they have some computer science experience, I guess. Yeah, usually a minor is, like, substantially shorter, though. And requires, like, less less classes of its field, at least. Because it's supposed to be, like, more secondary. That doesn't stop people from doing, like, dual degrees, though. Like, or, like, double majoring, for instance. Okay. Let's yoink this. Let's see. We'll do this, I guess. I don't know. Have you done the minor while doing the major? Yeah, they are at the same time. Or at least usually they're structured to be at the same time. Let's see. How do we even want to do this? Maybe we just make like a static function. Static, or C++ static class static method. I guess we could just do it like that, huh? That might be nice. Yeah, okay, let's do it like that. Yeah, I appreciate it. Yeah, okay, let's add a static method. Let's just yoink the thing from, let's delete this first. And then let's drop down to here. We can do that. That's perfect. How's the job market? It's no different than like the rest of tech, to be honest. I think everything kind of just like exists in that sort of bubble, for better or for worse. Oh man. Youch. Okay. Alright, we're gonna need to like re-implement some stuff, but that's fine. Overall it shouldn't be that worrying, I think. We'll just do this. Yeah, let's take that out of there. Let's go over here. We don't need this anymore. We can get rid of that. Okay. We'll move this over here in a second. Where exactly is it required? What the, oh, I see, whoops. And then, member name, or are we dead ass right now? Oh, I need to import literal. Okay, let's let's resolve that real quick. Wait, no, we have literal up here. Unique pointer. We need unique pointer? Is that? There's no way that's what we're missing of all things. Okay, I guess that is what we were missing of all things. Okay. Yeah, FPGA is like one big area. That stuff is like very interesting for compilers. There's also like big tech, which is like obviously like making new programming languages. They need like people to work on that. Quant invests in some compiler stuff for like FPGA reasons and also for like C++ development reasons. Yeah, so it's mostly just like hardware, big tech, and like some quant. Yeah. Okay, let's, oh man. This is rough. Let's do this. Have you implemented static analysis, or are you doing code gen directly? I haven't really done a lot of like, I guess there's like some static analysis insofar as like, how broad are we defining static analysis? Okay, I guess like if we're counting like an optimizer, which I guess like makes sense, but like if we're counting like an optimizer static analysis instead of like the conventional like just like linter sort of level, I do, yeah, optimizations I'm like working on. I have like mem to reg implemented, or I guess like SSA construction. There's some like basic folding, there's some like control flow graph cleanup stuff, but I'm like slowly trickling optimizations in. The big thing that I'm like working on, not right now, but like previous stream and hopefully next stream, and forwards, will be GVN. So, yeah, it's gonna be a good time. Okay, let's implement this chud literal map thing. What's wrong here? Oh. Okay, let's return lm, or can we can just yoink this. Yeah, we'll just rename this. That will port a little bit better. How do we use that in here? How do we do this? Wait. Oh, I need to... I see. That's what I'm missing. So we want... this ugly thing. Right? We want literal map literals like that. Is that good? Define out of line? What do you mean? Can we just do that? No. Ugh. God damn it. Do you want to explain what you're working on right now? Yeah, sure. So I guess yeah, let's just so I'm making a compiler from C to x86-64. If you're not familiar with compilers, they're the programs that translate our programming languages to either other languages or like machine code. One of the steps of that is like optimization and like making the code more performant. Right now I'm like cleaning up my infrastructure. So like those optimizations are run in like passes, and the idea is like you can run multiple of them in like some sequential order that like transforms the program. Right now I'm like cleaning up my infrastructure a little bit, so you don't need to like... So hopefully I guess my future development is a little bit less messy, because we have some really nested functions and it's like quite gross. Specifically like this is a lot of indenting, and it makes me very uncomfortable to look at. I'm taking this class in stack analysis. Ooh, hell yeah. Yeah, I think the optimizer is like the thing that I find the coolest. So it's cool to see someone else also appreciating it as much as I do. How are you compiling C with C? There are already large production C++ compilers, so I'm using that. How do I start studying compilers? Hopefully this command works. We'll see. If Nightbot... Okay, perfect. Yeah, those are my recommended beginner resources. No object modifiers? Okay, sure. No direct static access. Wait, what? Oh, I need to make it static. I see. Yeah, of course. Wait, this is static. Oh, this isn't static. Okay, there we go. So we just need to do this now. Okay, perfect. We figured it out. Yeah, it is another compiler. Yeah, I just like learning about things. So we're gonna learn about things by making things, pretty much. Yeah, I think this should be fine. Yeah, so that's moved. We can get rid of this now. And I think all this should still largely be functional. Yeah, so that only exists in like here now, which is perfect. We just need to update this slop. Yeah. How do we do this? Can we just delete that? Can we delete that? And here, we don't need that anymore, I think. That's all fine. We don't need this anymore, which is so nice. We don't need any of that anymore. We don't need this anymore. This is the only place that we care about now. This is just the getter again. Are we dead ass? Okay. Yeah, this is like the same function. This is like dead ass the exact same function. So we can just, let's just delete that. Get literal. Like, that's a little bit ridiculous. I think. So there's a lot of places here that breaks now. I think we're in the, yeah, so we're in the MIR literal map. Yeah, we can do that, I think, right? Oh, other way around. So I32, comma 0. Yeah, okay. Oh, man. So let's change this now. Oh no. This is so ugly. Can we just yoink what we wrote a second ago? Paste. And then here, E, get atom. Yeah, we should just like pull this out anyways, I feel like. Right, it looks like we have that, regardless of what type of that is. We can clean that up like that. That's nice. Okay, next place. You can check by comparing. Yeah, exactly. That's part of why I chose to make a C compiler, actually, because then I can necessarily like do one-to-one comparison with it. And I think that's just like a really cool goal of the project, at least. Where the hell did we go? Okay, let's just paste over that, make this 0. We'll replace this with -1. Yeah, that's all of them, I think, which is very nice. We'll see if this is all performing the same now. Let's rebuild. Hopefully nothing segfaults. Oh, come on. Inst combine, I see. That makes sense. Yeah, that's the only place that we forgot about. So we just do that, I think? We need that, okay. Sure. That's perfectly reasonable. Let's try that again. And then we'll rerun tests. Hopefully nothing explodes. That looks good so far. While this runs, I'll take a sip of water. Stay hydrated. Yeah. Okay, cool. So it looks like nothing breaks, which is good. Let's make dist clean. And then we rebuild again. Because I'm not sure if it actually like cleaned properly. I'm always suspicious when it like doesn't make any changes. And that's like completely my fault. But it looks like everything's running fine, so I'm not particularly concerned. So we'll just cut the test there. If everything is like the same up to there, and we know like everything is running correctly, then that should be correct at least. So we can add all that. What was the pattern called again? I already forgot. Monostate. Monostate if I literal map. Oh, we need to format. Oh. That's actually very nice. I'm very happy with that. What language is that? It's C++. Yeah, C++ is just so deranged. So yeah, it looks quite ugly nowadays. Yeah, I think we've cleaned all that up sufficiently. There we go. Cool. So that's one of the big changes we wanted done today. So this one we can say we have finished on. So the next thing is we want to split up inst combine. The reason is we had like a dependency on I want to split it up into like a function level pass as well as like a program level pass. I was unable to make the function level pass because it needed the program because the literal map lived inside the program object. But now it doesn't do that, so I have no reason, or I have nothing that like blocks that. Aside from that, I'm also thinking about just like splitting up the inst combine pass into like multiple. Just starting to learn Python, so this look funny? I see. Yeah, Python is a great language. I hope you have a good time with that. Yeah, okay, let's go back to this. So, maybe actually what we could do, we could, yeah, I mean, I guess we do just have to like, okay, we can yoink this. Let's paste this in here. And then we can yoink some more. We can yoink some more infrastructure from here. So this goes at the top here. Python uses tabs. Yeah, I mean, like, the indents are like ugly, but it's like fine, to be honest. I don't think it's like the end of the world. I think it's, if anything, I think it's a good way to teach newer programmers how to, I guess, or just get newer programmers used to the idea of like uniform formatting. So I think in that sense it's like not even that bad. Okay. So we need to change this signature to mr function star f. And then we can get rid of one level of that. And this should just be just f, return. Yeah, we can do that. Yeah, and then the rest of this should run about the same. The other thing I was thinking about is splitting this up into like smaller subpasses. I think that might be like an interesting activity, because then we can be more granular with like pass run order. It'd be like really funny. I think that might be like something that's fun to try. So we might give it a shot. Yeah, let's rebuild this, make sure it all runs fine. Okay, it got to LR without breaking, I think. So everything should be good, in theory. Okay. Yeah. Where the hell did I go? Am I still in the same... Yeah, I'm in inst combine, okay. Yeah. Git commit -m split inst combine into function pass as well. Okay, so now we can have fun. Yeah, let's make inst combine also do other things. So we're gonna want to define more classes in here. So if inst combine, oh man, this is gonna be great. Let's do constant fold. So all of these things, all of these like lambdas, I feel like we can just turn into a function, because I really don't like how nested this is, and it's just like, it's really irritating me. I know that like this will probably result in like a different simplification order, but like I think it's better to define this sooner than later. I also think it's just like fun to do it like this. So yeah, we'll give it a shot. Um, yeah. So we have that. Simplify arithmetic. I guess we could yank this again. Yeah, let's yank that. There we go. So all of that should be fine. Oh man. This is gonna be interesting. This is gonna be really interesting. How do we iterate through things here? This is... Oh wow. This is per basic block even. That's crazy. So what do we even do with 2 drop? I guess we just move it, which is crazy. I don't think we even need this. I feel like we could just do the erase instead of like doing this like 2 drop thing. Right? Like unironically. Let's try that out. I think there was a reason for it, but I don't know. Let's just give it a try. And we'll see what happens. I think that's always the more fun thing to do. So we've only made changes to the header, so if anything goes wrong, we can just undo, or we can revert all changes in here, at least. Yeah, because it just gets dropped anyway, so like what's the difference, right? Like, yeah. Okay, let's try this out. If this breaks, it'll be really funny. If it doesn't break, it is also really funny, because I've just been doing extra work in my compiler for no reason this whole time. It appears that we have been doing extra work for no reason this whole time. Yeah, that's marginally annoying, but you know, it's fine, you know? Like, yeah. Okay. That also seems to have run a lot faster, which I think is pretty funny to think about. Yeah, anyways. So, yeah, that's much better, actually. I kind of want to commit this temporary thing, just to like laugh at myself. Let's do that. We don't need to drop. We can just erase, lol. Okay. Anyways. This is also nice because now we can do it like per basic block, which I think is fun. Yeah. So, what do we want to do with this? I guess. Do we want to do like a pass over all basic blocks? I think that's like a little bit ridiculous. No, we do want to do it that way, because changes in one basic block might propagate down to a different block. But we can still probably separate out like a basic block level pass actually, which is fun. Yeah, so we can do that actually even, I think. We're gonna give it a try at least, and if it doesn't work then like, Dala. Okay, so this is the purple brace, so we put it here. And then we do baby. Okay. So can we just like move everything in there, hypothetically? Yeah, so this is the yellow brace. I think this one? Yeah, okay. Let's do that. Oh man. What do we do here? What's wrong? Changed. I see. How do you want to do this, actually? I think this might end up like really slow, but it's like, it's probably fine. it's probably no different. If anything, it's just like less passes or less sweeps across it if we just like go as deep as we can in each basic block. At least in theory, that like makes intuitive sense to me. Yeah, so let's do another like while changed thing. Let's see. Yeah, so we want it to be like here. Changed equals false. And then we can move all of this in there again. I think it's that one? Yeah. Oh man. So we're back to this, but there's less nesting this time, which is very nice. That's a little bit prettier. Yeah, so that should work in theory. So we try it out. If it works, then we change and we continue. We need to reformat this though. Yeah, because we've pulled it out 2 levels now, pretty much. So yeah, that all works. Yeah, again, this like lambda thing is annoying, which is why I want to make these helper classes. But yeah, we'll try it out like this for now, and then... Oh man. It's not a good way to do this, actually. Now that I think about it. We might just have to like... God damn it. We might need to make this like a boolean. Which is the other really funny outcome. Let's just like... What is the best way to do this? Let's not make the basic block level 1 for now. And let's just like try to... Let's just try to do it like this for now. Let's try to implement these other ones first. Yeah, let's do that. So let's... Oh man. Yeah, the program level one's kind of just an adapter. So I think that's pretty reasonable. Yeah. So this should be constant fold run. And then the function one we'll do in a second. For now, let's do simplify arithmetic. We could even do this on the instruction level. That might be funny. Do you recommend the Thorsten Ball compiler in Go book for starters? There's someone in chat that really does. If Lane is around, he could probably give his thoughts on it. My recommendations are still above. I think the bot posted it, but just in case. Yeah. Give it a second. There we go. I'm sure, I don't know, I'm sure like Thorsten Ball's book is probably fine though. I just haven't like looked into it, so I can't really like give an official recommendation or anything. Okay, constant fold. Aye. Let's do that. Okay, now we can... Oh man. I'm so scared. Is this gonna... I don't know if this is just gonna make it like really slow if we do it like this though. I think as long as we like frame it as an adapter, I think it's probably fine. I guess as long as we implement it like an adapter, it should be fine. I guess another thing we could do is we could kind of like, we could make a subclass of transform pass that has like this, and that might be funny. Oh, I really want to do that now. Fuck. Yeah, we'll do that. We'll do that later. For now, let's just worry about this. Yeah. So, all right. So we want to yoink some of this out, I think. So if we can pull try constant fold, and if we can just like put it in here. Static casting is static cast. Where is this? Oh, yeah. There's like a type conversion order that matters for it. Because this is, I believe, an unsigned 64. So I want to shrink it, and then I want to turn it into an int. But I don't remember what I was doing here. So there is a chance that that's also just like complete nonsense. Yeah, it's been a long time since I've like actually maintained this code. So we'll find out the hard way, I guess, if there's any bugs surrounding that. Yeah, let's can we just I feel like I should just like yank all of that. Or we should just like yank everything here, and then we can figure out it out as we go what to delete. Evidently that was one too few lines. So we want to yank that. We can paste that in here. Oh man. Let's just work on this first. Okay, so we need this guard at the top anyways. There's a little bit of overhead that comes from that, but that's like fine. Yeah, this is like fine. Let's just do try constant fold. We can delete try simplify here. Like that. Okay. So instead of this, continue. Oh, Jesus. I think the continue is fine in the switch block. Then here, changed equals true. And then we can just like yeah, and then we can just do that, right? Oh yeah, we need to increment the iter on all these continues. Right? Where am I? Okay, I see. Oh, that's kind of ugly, actually. Yeah, I guess we do need to do it like that then. Yeah, I mean that's kind of inevitable. This is the cost we pay. Yeah, okay. I think that's, yeah, that should be good. And then we can delete this. We don't even need to continue there. Okay. So that makes sense. Alright. This is much less nested, which makes me feel better. Even though this code is still egregiously ugly. That does make me feel a little bit better, at least. Let's just try to do this. Yeah, let's just yank this. And then if we can reuse that down here, that might be interesting. We might just have to like nuke the body here though. Yeah, so we can get rid of that, and then we want to replace it. This is like a little bit duplicative, but hopefully I can find a way to deduplicate a little bit of it. I think that'll be interesting to try out. Okay, let's yank everything in here. Okay. Oh, Jesus. Okay. Yeah, do that. Iter plus plus, continue. Oh no. Oh no. Okay. Oh no. Okay, I guess this simplifies a little bit nicely. Yeah, we can do that. Then here, we can do iter plus plus, and that should be it for that. Yeah. So that should just be correct. And now we can just like replace stuff in here, which is a little bit deranged. Why am I splitting these up actually? This feels like a bad idea. Now that I think about it, this feels like a very bad idea. I guess we don't have any dependency anymore on external things. So we could just like, since we've like implemented these separately now, we could just move these inside of the inst combine thing, right? I think that's probably the less ugly way to do it. I don't really like the duplicity of this. We could use this to like define a custom like inst combine or something though. And so we'll just like make helpers, I think. Yeah, so let's just do constant fold. What do I even give it? Are you creating your own programming language? No. I'm making a compiler for the C programming language, and it translates down to x86-64. What type is iter? I think this is a terrible idea, the more I think about this. I'm really scared. Can I just like, is it reasonable to pass C++ iterator as function parameter? Ugh. Yeah, I don't want to do this. I don't like that. That's very awful. Oh man. Okay, I don't like this. I really don't like this. Um. Huh. Yeah. Hmm. Yeah, this is not very enjoyable all of a sudden. Um. Maybe we do just leave this like ugly lambda thing. Just out of curiosity, I'm gonna try to do this for constant fold. Because we kind of already have this like scaffolded out a little bit. Maybe we could just do it like across basic blocks instead. And that like lets us wrap the iter. Yeah, because we do need to like I guess we have a true, so we could just return true false for iter. But then like how do we handle insert and delete, right? Like that seems awful. That seems a little bit awful. We could make it take like a success buffer and like, yeah, that might be really funny. We could give it a pointer to like save a new instruction to. Is this tmux? Yes, I'm using tmux in Western. Yeah, how do I want to do this? I guess we have like replace uses, so like it's not that bad. We could literally just do that actually, now that I think about it. Right? Wait, hold up. Wait. Okay, so where do we even use iter here? I guess we don't. Oh. I guess only insofar as like we erase here. But like simplify arithmetic. This might require us to insert at an iter, which is what I'm scared of. I guess we just replace uses then. So like it's probably fine actually. Right? Like I guess here these are all like identity. Right. There's no world where we like insert something new. So I think surely this is like fine because this is like necessarily combine. Right. So this might actually work. This might scarily this might work. Yeah, so let's try and implement this just for fun. Let's give it an instruction star I, and that needs that here as well. Yeah, so this is a little bit ridiculous, but we'll see how this goes. I think we can, in theory, just like yoink all of this pretty much, and then we can make some small changes. Let's change that, continue, or turn false. So we're going back to return false, which is funny. Yeah, we need that here again. Yeah, I think a lot of my viewer base is either like in college or not in college yet, which is really cool to think about actually. Okay, this actually de-nested surprisingly well. That is very nice. I think you could just make this a little bit cleaner. And this cuts out a guard. What the hell? Have you ever needed a 95 in a final and passed? I think so, yeah. I think I remember an instance of that. It was pretty cool. Okay, so we have this constant fold function now, so we can get rid of this chud function. Okay, so let's do this again. Simplify arithmetic. Yeah, let's just yank that. Let's paste it over itself. Yeah, so we can... I forgot an H. There we go. Now we can delete this again. And then we can yank this again. I think this is about as much as we need to yank. Or up to the purple brace, so it'd be here. Yeah, so we can do that. Do that. Return a report? Damn. That is rough. Okay, we're changing this back to return true, which I think is a very ironic outcome. But that's fine, actually. Late assignment. Yeah, I haven't cut it that close ever. That's pretty impressive. Yeah, and then here, return false. So now we can delete that. So this denests much better. This looks much prettier. Thank goodness. So now we can clean this up somehow. I think we can get rid of all of this now then. Like that. So we constant fold, we give it I. Simplify arithmetic. We give it I. Then we do that. Okay. I'm not sure if it's better to like exploit locally as much as possible. I think this is probably a fine implementation at least. Oh, we need to erase as well. Oh, where did that erase code go? God damn it. Ah. Yeah, we need that. We need that line. There we go. Much better. Okay. I'm a lot happier with how this code base looks now, at least. This brings me joy. Oh man. What else do we need to do here? I think that's actually like pretty comprehensive, at least for cleaning this up. And then this is nice because then we can also like reorder things as well in the future. Yeah, maybe I should do like a basic block pass version of it as well, but I think that's a little bit redundant at least. Yeah, we can just leave it at this. Let's rebuild it just to give it a try. This should all run exactly the same. This is just one big refactor. This feels faster, at least. Okay, well, as I say that, this takes an eternity again. Okay, so the other big thing I want to do is I want to, like, make a function pass class. What did I... Oh, I see. We're in the same file. Okay, let's add commit. Let's see. Clean up or finish denesting inst combine. Okay. So the final thing I want to do, I have had to write like this function multiple times. I'm starting to think that I shouldn't need to write that so many times. So we're gonna make a function pass. We're gonna make a function pass class in pass. Yeah. So let's. That is a type of transform pass, at least. Do we have any analyses that are functioning in the same way? Yes. Okay, all of them just do. Okay, I mean, like sure, okay. Yeah. Let's see. We could give it a function type, and then, yeah, how do I want to define this actually? This is very awkward. Alternatively, we could define the function type, and then, like, default it. Huh. Yeah, this is interesting. Maybe we could just, like, define all of these. Okay, let's... We could make this something, and then we can default this. But then there's, like, overhead and, like, Okay, I don't like that either. Huh. We could make a... We could make a function pass separate from a pass. And then... I guess we could make, like... Huh. This is really stupid. I need to redesign this. I should just, like... We should just, like, have, like, a preserved passes thing, like LLVM does, instead of, like, having these sorts of separate analyses. But, yeah. Well, I guess that's, like, a next time problem. Or a future problem. Let's push. I think that's a pretty reasonable place to call today's stream, though. Thank you all so much for showing up today. If you haven't already, like the stream and sub to the channel. It helps out a lot with the algorithm and gets my content out to more of you. While you're down there, check out the description. My Discord is there, you should join. My GitHub sponsors is there if you want to give me money. And my GitHub and my LinkedIn are there if you want to add me. Yeah, I'm going to go eat more food now because I'm kind of hungry. Take care, y'all. Take it easy. Thank you all for stopping by, and I will see you all tomorrow.